Okay, so the goal for today was to come up with several different prototypes for each mechanism in the game and hopefully have them done by the end of the day so that we can start prototyping them or start implementing them into the robot. So starting off with the shooter, the two types of shooters we plan on prototyping is a C shooter and a two-wheel flywheel, which would have a variable angle. The intake and hopper, it's going to kind of depend on which shooter we pick. We'll most likely definitely have a roller bar, which will be something that like kind of falls off the edge of the robot and have wheels to spin in the balls to get them into the robot. So if we do a C shooter, after that it'll have like some kind of funnel in order to get it to the other side of the robot to the C shooter to shoot it back up. Now if it is a two-wheel flywheel, then we'll try and make the shooter also be part of the intake. So after the ball comes under the roller bar, it will suck in the ball and up a tube. And that way, whenever we're ready to shoot, the shooter will just angle up and the balls will be gravity fed into it and it'll shoot off. So for the control panel, we're just going to use a wheel to spin it. We're just going to mess around with the placement of the wheel. We might place it on top and just, this is kind of like a section view of it or a cutout view. We're going to have the wheel just drop down here and spin it on top of it. Another possible thing is we might just have a really thick or like two wheels right here that would make contact with the two layers of it in order to spin it around. Okay, so the climber, if you read the game manual, the climbing portion of the game is worth like the most points, and so we really spent a lot of time coming up with ideas for this. So the first one we had was like a measuring tape. So basically the idea is stacking two measuring tapes on top of each other and using that to get the hook all the way up to the bar. Then we have pneumatics, rack and pinion kind of worm gear system. An elevator, so that would be like a three-stage or two-stage elevator just to get the hook up, or possibly a folding arm that could get up and just hook on it. So the ones we decided to prototype was a measuring tape and the elevator is what we'll be going for this year. The other thing we talked about with the climber is like, are we going to have a hook or what are we going to use to do it? So one of the ideas that was brought up is having something where it kind of hooks on both sides. So it'll help center it and help us latch on. So we'd have two sides and possibly like a spring right here pulling these together. And we'd push it up, it'd open and come back in. That way it kind of looks like this as it comes back down and you for sure have a good latch on it. But you would obviously be very stuck on there until someone freed it. But that's kind of what we want. We want to have a secure latch on it.
My group was prototyping an intake mechanism, and we decided on a roller system. When we finish it and it'll be on the robot, it'll be about as long as the hex shaft actually is. We'll have about 2 more wheels on it, and it'll drop out of the robot to suck up the balls. We decided on this with 2 inches of compression on the ball, which you can kind of see if I just stick it underneath here. We played around with it a little bit. We started with 1/2 inch, but then after messing with it, we decided 2 inches of compression was optimal, leaving about 5 inches from the wheel to the base we have right now, which would be the ground.
So this prototype here is a double flywheel shooter. We made it with 2 mini sims, and those directly drive the 2 flywheels. We started with a spacing of 6 inches with these 4-inch white tread wheels. We found that it shot pretty well, but we thought it could use some more compression, so we took the gap down to 5 inches, and it shot much better and much more consistently. And then we wanted to keep playing around with it, see what worked and what didn't work, so we switched these wheels out with these 3 1/4 inch gray tread wheels, and it shot pretty much the same, if not better, so we kept it.
All right, this is our C shooter that we prototyped. We are using a 4-to-1 increase here from our drill that we use to spin it up. We have a space of 5 inches between here, which is providing 2 inches of compression on the ball. And this prototype, compared to our double flywheel, has been noticeably a lot less reliable, and we just haven't had the time to fine tune it up. I think it's a viable option for some teams, and I just don't think it's for us. I think we're just going to go with our double flywheel that we've built, because it shoots the bar a lot further and a lot more accurate than this is.
So my group created an elevator lift for the final end game. We're planning to attach a hook onto here to be able to attach to the generator switch during the end game. Our general design is using 80/20, 2 separate beams of 80/20, and this one right here will be this is a scaled down model. This part right here will be attached to the main robot, and this right here will be raised and will be elevated and will be connecting to the generator switch to engage the hook. Our system works by having a spool down here which connects to a pulley near at the top of where this will be 45 inches from the ground, which is the maximum ground clearance for the robot, and this pulley will connect to the bottom of our secondary beam, which will be elevated, and the distance here, as I said, is 45, and in our final prototype, or in our final robot, this second beam will be an additional 36 inches, which will give us plenty of clearance to be able to reach the generator switch whenever we decide to later on in the match. This type of system has several pros. The main reason for us being that it's relatively quick and it's very strong, and it's able to raise effectively and reliably as well. In that it's a very simple system. It's just a pulley and it's able to raise up. So the cons of this type of system is the weight, obviously, as the 80/20 is relatively dense and it adds lots of additional weight to the robot. And additionally, it only works in one direction, meaning that once you are able to attach to the generator switch, you're going to have to use a separate mechanism to be able to bring the robot up. As the rope, once it's engaged, it's not able to pull the robot with it. So what we're planning to use is something similar to like a winch, and we're going to, once this is attached to the generator switch, we pull ourselves up with the winch and use a separate motor, separate system. This is just like a first step.
Okay, so we decided to do a prototype climber with measuring tape, and some teams have done it in the past and it's worked out really well and it's really cool, so we want to try it out. And basically we unscrewed 2 measuring tapes, stuck them together, and then tried to like extendotron them out. And it's a really cool concept, and it can extend to the height we need. However, it is really hard to spool it up right, especially out of its casing, and it's hard to get to extend properly and constantly. It is possible, however, we don't think it is feasible for us to do in 3 days and have it really good.
The wheels have lost their ability to turn on the axle.
Go, go! Push out.
Ooh. Joe, you don't even run the pull the hook out. You are going up.
Woo! Woo! Okay.
Uh-oh. Uh-oh.
Suck it in, but not too quick. One more time.
So we decided on a wheeled intake to get the ball into our robot. These are the final decisions we've made, just to make that clear. This is our base start for our robot. And then we have the flywheel intake to shoot it up, this hopper tube, which the ball fits into, and this is how we'll be storing it. We might be having an agitator here. We're still working on the logistics of that. And for the generator switch, we have an elevator mechanism that we're still prototyping the hook for. And tomorrow we plan to prototype a wheel for the control panel, but we haven't started that yet. And that's all we have for today. We'll see you guys tomorrow.